Hey guys, we're back and we did it. So that's pretty exciting. But I think there's more celebration for once we burn the tokens, which I think is going to be in about a week or so. Uh, we want to make some sort of hoopla out of it. So yeah, another Gleam campaign so we can get that, get a whole bunch of retweets and eyeballs on the live stream where we actually, you know, burn like 90 million of these tokens and then, you know, woohoo. That being said, uh, today we onboarded officially 5 more developers to help with the production of our application. I'm going to run through the basic strategy of what we're doing. So the core mentality is to start small and to produce something that can stand alone in itself and then build additional complexities off of it. So you build what's called an MVP, a minimal viable product, that can be validated by, right now, developers, but that kernel can be built into an API, which then can be built into a web app, which everybody can use, but it's still formed from that small sort of IP. So the kernel that we're creating right now is atomic swap generator, which is not anything that's too crazy. But we haven't seen it been done in a way that's user friendly. Decred did atomic swaps, and it's not developed in a way by which you want to go ahead and use it. So it doesn't make a lot of sense. Now what we're doing is we're developing a Python library that does a lot of this stuff. I mentioned this prior, but atomic swaps can be supported right now without changing any code in Bitcoin-based chains. So Bitcoin, Litecoin, Zcash, Dash, Z Classic, right? Z whatever, any of the Zs, any of the Litecoin derivatives, Feathercoin, any of the crazy, Dogecoin, anything that was just like, oh, we're basically Bitcoin, but we changed the block size and the block time, right? All of that, same thing. Even up to the complexity of something like Zcash, still is forked from Bitcoin. We can atomic swap between any of those off the bat. And what that allows us to do is then decentralized trading in between those. Of course, if you have a whole bunch of different assets, you can't really make a whole bunch of markets in between them. So, I mean, if you have a whole bunch of different coins, this is kind of what happens now, right? Inside an exchange, you have to convert to one to the other. In the decentralized exchange, you can basically say Zcash to Litecoin. I don't think that market exists anywhere. Now, what we're doing is instead of having some sort of US dollar or something like that in the middle, we want to create a decentralized market. Let me get where is this? Where we take these atomic swaps. And now the Python library will do this pretty well. Ultimately, it's going to turn into a web application that people can use, and it turns into a marketplace, right? And so once we start creating these different atomic swaps in between these markets, let's say Zcash and Bitcoin and Litecoin, what else? Oh, I don't want to say Tether, Ethereum, let's say ERC20, right? Now these can all communicate with each other, woohoo, right, in some sort of seamless way. But this information still has to be processed by somebody. And the problem is that once more people create things with their toolkits, there's not these direct markets that are going to exist. It's just going to happen. So if you have Stu-Bucks, maybe no one wants Stu-Bucks except 5 people. 5 of my friends want Stu-Bucks. And so having a Stu-Bucks market to something else is just not really going to happen. So that's where this tau token comes in. Where we put the tau in the middle. And so you can then route. And you only have to have one market, right? You only have to have Zcash in transactions and Ethereum out transactions, right? It's just like 2 sides of the market. So you're buying tau and then selling tau. So in, out, right? what this basically allows you to do is you can have tau and you can convert that into other assets really easily because all you have to do is find one of these cells. And so if you have some sort of exotic, stew bucks, so stew bucks, right? I just have to get this into tau from some market, right? And I can do that because I have 5 people who are kind of using my app. All right, sweet. Now I can turn that into any asset, right? Or maybe what I want to do is I want to go out to the community and say, hey, look, stew bucks, come fund my stew bucks, stew palooza, right? And I can say I accept any crypto because if you can have an in transaction to this network and you have tau, now you can have stew bucks, and I'm selling my stew bucks for 100 tau per stew bucks. Very rare commodity, right? So now I can pipe in any crypto, right, off the bat. But there's still this work that has to be done to make this happen. Now, this is where this decentralization occurs. So a lot of the ways that we think about decentralization is in terms of a blockchain, where we say, oh, there's participants, there's miners. Miners do all this work, and the only work that they can do is either they're hashing or they're signing blocks, and they're putting blocks on a blockchain. That's all that I know, right? But a decentralized network can do a whole bunch of other things, and decentralized networks have existed longer than blockchains and this whole revolution started. So what we're proposing to do is that if I want to enter an exchange, right now, ironically, things like Ether Delta don't really work well because it's still centralized in the fact that it's an interface, they have Ether Delta servers, and they have to manage all that infrastructure. Now, the actual operations of where the data is being stored on the ledger is on Ethereum. We still have to interact with this, and IDEX had this problem too where, we had huge volume. But there's still a cloud point where IDEX needs to expand their servers and they have to, do some development operations to make sure everything's good. And if they get attacked, that's a problem. And so how do you keep this scaled? So what we propose is that instead of one entity creating the market, right, and saying everybody come here and the atomic swaps, occur on our market. Now, that what we propose is that you can connect a node into our network and suddenly offer up a piece of work where you say, look, what I'm going to do is I'm going to build the transactions and I'm going to handle these things so I can be a market maker. And really all that I am going to do is say, all right, look, I'm going to take an in transaction of Bitcoin. So Bitcoin in. I'm going to see that in this big queue, right? You can think of the market as a big bucket. Sometimes it's like a queue where everything's getting dished out. Sometimes the market's, you put up the order books and based on the price, then it triggers things. But all that information is, that can be done later. What the real clog point is processing these actual transactions when they occur. So you connect your computer. And a decentralized network is like a peer-to-peer network. So think of like BitTorrent, right? So there's a whole bunch of work. Some people know more, and they share it with everybody else. It's a swarm of information. Similar with this, all of these orders can be tickets. And then basically I go and I grab a Bitcoin in, and I say, look, somebody wants to take these Bitcoins, and they want to pass it to this person, and they want tau in exchange. So we're going to just erase this now. So if we have the Bitcoin network and we have the Tau chain, which I should not say, Cilantro, Tau chain's actually an Agora project. So, and we have A, B, B. Where there's 4 wallets owned by 2 people. Each one owns a wallet on each chain. So we pass the Bitcoins to this person, right? And then they pass the tau to this person's. That's the exchange. I give you this, you give me that, right? So 2 transactions. What I have to then do as someone who's working on that is I have to submit this transaction to the network. To make sure that happens, I have to submit this transaction to the network. Now, I don't have to own any of these things. Like the UTXOs can be deployed, and then necessarily those rights can be then sent. Of course, the owner of that has to sign it, and so that's a problem that we work on. Are we going to have one-time use addresses that then, you have A, and then as I'm a worker, I have C and D, and you basically say, I give, these rights to this person. There's a whole bunch of other things that we need to work out here. But the point being is that if I am someone who can commit my work to this network, I can say it costs 1 tau, or it costs half a tau, or a third of a tau for me to do this. And if you accept this, then I'll do the work. And what that does is it creates an economic incentive for people to join, and then it creates a decentralized network. And the thing about decentralized networks is that they're really robust. And the fact that there's multiple points, and if one node goes down, it doesn't matter, and it can't easily get overloaded because you can distribute the work across, let's say, 1,000 different nodes, right? And so also what's interesting is if your computer is geographically located towards different nodes, it can just connect to those nodes. So if I'm in Africa, right, and I'm trying to connect to somewhere in Alaska, that's obviously going to take a very long time. But if these nodes that are distributed across the world keep a relative check on each other and they distribute that work, well, then I can just connect to the node that's closest to me. I can submit work there, and then that can be propagated. And then things are a little easier that way. So that's this network. That's what we're working on here. And so this is where the tau gets introduced into the market. It's not necessarily saying, oh, it's this great thing, and oh, it's going to be this, it's going to be that. You build the atomic swaps, you demonstrate the actual value of what it's going to do, and then the problem is that you can't make markets between all different 100 coins because it's like 100 factorial different permutations of markets. Or you have 100 markets that all attach to tau, and then it's a lot easier to process, right? And we can decentralize it like this, and then it's good to go. And then it's like, what do you really use Ethereum for? CryptoKitties, right? What do you really use tau for? Atomic swaps. That makes sense, right? And now I don't have to rely on Tether, which could explode at any single point. I don't have to rely on Bitcoin, which it has all these problems and it's slow, right? And it's bloated and it's expensive. So what this does is it eliminates a lot of that. And so you can see the strategy here being less so based on speculation and saying, oh, like when this happens, it's going to be like this. We're focused more on demonstrating that this is something that needs to happen, right? Decentralized exchanges are the way that the industry is going, and they all are horrible right now. They all suck. But we can use this to our advantage to introduce the power of this entire network that we're creating. Because as an interoperability token, you can interoperate. And so start with the main chains, right? And so there's already there's 100 different coins that people probably trade and stuff like that. And you can interoperate with most of them. Some of the novel implementations would need a novel atomic swap. For example, Monero. Very hard to do atomic swaps with Monero. Bytecoin. There's a whole bunch of other ones. Bullberry. They are like all these crypto nodes, right? Hard to do this. Okay, well, we can solve that problem later. We can have the community create an implementation of that atomic swap, then supported by this network, right? Same with the Lisk. What is Lisk doing? I don't know. Does Lisk support atomic swaps? If they ever release their SDK, then they will, right? But we can't do that right now because we don't have the SDK. In the future, though, if we create the interface for people to develop onto new technologies, then they can, right? And they can develop an atomic swap for the app that they create with our toolkit. And 10 years from now, when, EOS squared comes out, all right, sweet, that atomic swap, boom. You don't have to change anything. The blueprints are there. It's all about infrastructure. It's all about kind of extracting yourself from the actual implementation and saying, how are things going to happen? And then build within this scaffold, right? So the scaffold can change over time. We can have better concrete. We can have you know, better pipes. But you're still building a building. You know, you still want to build this high rise so you can stack people on top of each other. It might be glass, right? It might be brick. We might learn how to make them way taller, but it's still the infrastructure play that you have a building of people that work there, and that is high value. So similarly, so my computer's going to sleep. Similarly, that's what we're doing with this. Build the infrastructure, demonstrate the value, and make a splash, right? And make the world reliant on this technology. Because once you develop the infrastructure and you set it down and you build that road, people use that road, and it's hard for them to stop using that road once they get used to it. And that's why, I mean, it's the same thing, right? I mean, you have to design infrastructure to be mutated in the future, right? We're seeing this with Bitcoin. But Bitcoin is powerful. So they have that kernel that I just said where people started using it, now they can't get off of it, right? And so make the road and then have these mechanisms, the road can be improved upon, still a road, still used to move people. That abstract thought of taking people here and moving them directly there without any burdens or sticks or animals or things trying to kill you in the way, right? Wilderness is very scary. That is important, and that's what stays in the world. So, architecture, trading things in a decentralized manner that can scale, is not reliant on a single power authority, and can mutate to different market conditions. No matter what, someone can charge 100 tau, someone can charge 0.1 tau. That is up to the market to determine, and it's not tied to necessarily anything. So it can mutate like that. The Bitcoin transactions are fixed. It's a fixed fee. It needs to mutate. So that's where we're going. You know, there's really nothing else to it. It's definitely not an easy task. It's definitely not a task that's impossible, because it's less about the idea and more about the execution. There's 100 different ways to execute this stuff. How do you execute it properly? If you make things too complicated, they fall apart because there's so many different holes. You make something so complex, it's like a BMW, one little part, boom, springs out the sprocket and the engine, and then it's $50,000 for that one piece, and you're like, what the heck? Versus, you know, a mid-market car that has like a Honda Civic, perfect example, cheapest parts around, all standards, easy to fix. I mean, you just slap whatever on there, that's a more successful car. It's not necessarily the best car in terms of like, oh, exceptional arbitrary quality, but it's a better car because it's more ubiquitous, it's more accessible, and it's more pragmatic to the actual world. And so that would be a more successful implementation. And that is what we're doing here. So that's a lot. And of course, congratulations to you all and us. Thank you so much for the contributions that we can make this possible and we can move this project forward, because this is the cusp. This is the cusp of something great. And it's only going to roll out from here. But more melodrama for the burn. Right? Let's celebrate that, and let's put the nose to the grindstone. Let's get this out. We're going to start to see a lot of interesting things coming out here. We're going to get more of a standard communication flow, so you can expect certain updates at certain times. And we're going to keep you more in the loop of, we got some interesting rumblings going on in terms of how can we make an even bigger splash with something like this? How can we get, you know, how can you push this forward as much as possible? So, yeah, stay tuned. It's been a minute since I did one of these, but we'll be back doing these more because it seems like people really respond well to them. So, all right, guys, take it easy.